We are on the sections 8.3 and 8.4, page 25. We are talking about what? Rational expressions. They are polynomials in fraction form, right? So, we are talking about fractions. And for adding and subtracting. So, let's review the numbers first with LCD for adding, subtracting fractions. So, if we have same denominators, what do you think? Right? 6 pesos plus 2 pesos would be 8 pesos. Over the fifth, so that would be 8 over fifth. Right? So if you have same denominators, same units, same measurement units, then you will just keep your units, keep your denominator, combine the numerator, right? For adding and subtracting, they are the same. Then, if they have different denominators, that means if you have pesos and dollars, so you want to change to the same pesos or same dollars, right? For this instance, 5 and 20, we want to change the same thing. That would be what? Which one both can go into? That would be 20, right? So LCD is 20. Then for 5 to get 20 times 4, that would be 24. If you do it on the denominator, you have to do it on the numerator as well, right? This 120 is the same. So what do we have? Then you combine the numerators. So do we have the answer? Not quite. Why? Because the fraction, it should be what? Always the simplest form. So 5 can go into both. So your answer would be what? 1/4, right? So that's the numbers we are doing. Then let's talk about expressions, rational expressions. Rational means what? Ratios. Ratios means what? Fraction. Then expressions mean what? X, Y, Z, and numbers and powers, right? So if we have 5m over 2m plus, same thinking for the variables as for the numbers. If they have same denominator, what do? We just combine the numerators, right? That would be your answer. So, how many terms on the top? Binomial now. Can you cancel the n and n? Don't do that, right? Because this is the binomial, it's a group. You cannot cancel part of a group with the denominator. If you want to cancel something, it has to be what? By multiplication forms. That means what? Factoring style. Then individually for a group, you can cancel that way, but not a part of group with the whole group underneath, right? So that would be your answer. Next one. Adding and subtracting, they are the same, right? Just combine the top. Do we have same LCD, same denominator? So that would be that. Then, oops, that's a 7 on the bottom, right? Those are 7. So the top is same thing, 2y minus 7. Do you cancel part of the bottom, part of the top? Don't do that, right? We say this is the group symbol. On the bottom is a group. And for this group, is that simplest form? It is binomial. So if it's a group and simplest form as a prime, you put the parentheses around it. Okay? This way, you can cancel the whole group. That will be okay, but not the part of the group. Okay? I keep repeating that just because you will do that. Don't do that, right? Then we have same denominators, so we are going to what? Put the top together. For subtraction, you make a mistake here. So that's that. For the first one, that's fine. For the second one, when you have negative minus, you have to minus everything inside, right? So minus 10x, that's correct, right? But you make mistake on the second one because it's what? Minus negative 5. That would be what? Change the sign, becomes plus 5, right? That's another mistake you might have. So after that, you are fine. Combine the like terms, 3x squared minus 8x plus 5 over x minus 1, right? What do you think? Are we done? Why not? Or why? Right? You have to check. Like those 5 over 20. You need to check whether or not anything can go into both. You need to simplify. So for the trinomial, how do you know it's a prime? So you have to write a prime form first. So for that one, x minus 1 is a prime, right? Put a parenthesis around it. And this one, you need to do what? To break down a trinomial. We call it AC method. You need to try it. 3, 15, and negative 7. Something like that, right? So from previous section, we learned that. So we will not do it anymore. So that will be, I think, minus 5. Because negative 5 times negative 1 is positive 5. 3 times 1 is 3. In the middle, combine the like terms, negative 5x and negative 3x. That would be negative 8x. Okay? You need to do your AC method. So a group, you can cancel out like those, right? So the final answer is 3x minus 5. That would be your answer. Right? So what are we doing? We are doing what? Add and subtract rational expressions, right? And with what? With same denominators. Is that right? So with common denominators, you can just combine the tops, right? Then what happened? if you subtract the rational expressions, right, with what? Different with unlike denominators. Just like this one, right? Then you need to find the what? LCD. How do you find your LCD? So we need to find LCD first, right? How do we do that? So you look some examples on numbers first. So if I have 314 plus 3, 5, 21st, right? And to find the same denominator that 14 and 21 both can go into, find the LCD. Actually, we did this in 187 class, right? How do we do that? We do the trees, right? So you do 14, you break down 2 and 7. So your 14 is what? 2 and 7, right? Then your 21 would be what? 3 and 7. So those numbers are primes. You break down to the prime numbers, right? So it will be 3. 3 cannot line up, so you put it on the back. Then 7 you can line up, you do that, right? Then you line them up. Then GCF is the one they have in common, right? But LCD is what? You need all of them because those prime numbers are building blocks for each one. Then you want to find the LCD, both can go into it. That means it has to include all the building blocks for all the numbers you are looking for, right? So you need a 2, you need a 7 just once because it can be built from 7 to both. So that would be 3. So then you multiply them together. 2 times 7 times 3 is what? 1442. That means that's how you find LCD, right? And let's write down the steps. How do we find the LCD for numbers? And we will do the same thing for the polynomials, right? So we say, what will we do? So first, you will factor each, right? Each denominator completely. What does completely mean? It means to the primes, right? Then how do you find your LCD? LCD would be you multiply those all different factors, right? Appeared in the denominator, right? Appeared in the denominator and raised to the highest power. In any one denominator. Let's see what does that mean. Raised to the highest power in any one denominators. Okay? Otherwise, you know, you will multiply all the different factors appeared in the denominators for both of them, right? Then for the polynomials, you will use highest power in any one of denominators. Let's figure out what does that mean. Okay, that's for numbers. So for the polynomials, you use the same steps, right? And let's see some examples. So 9y over 9y and 11, 15y cubed, right? So we are saying to find the LCD for 9y and the 15y cubed. So 9y, 15y cubed, right? So numbers with numbers. So 9 and 15 LCD is what? 45. Because both can go into it. You can just do the trees and line them up. You will find the same number. Okay? For y and y cubed, y means what? Y itself. Y cubed means what? How many times? Y times itself. 3 times. So you need all of them, right, for LCD. So that will be what? Y cubed. So y cubed is higher power in both y and y cubed. That's, we need to choose what? Higher one, so both can go into it, right? So you choose highest power in any one denominator. That's what it's talking about, right? So what are we doing? We try to do what? Adding and subtracting the rational expressions, right? With unlike denominators. But first, we have to find what? LCD, right? So right now, we are finding the LCD first. Let's look more examples. So for this one, so what do you think? What's your LCD? So one of the denominator is this one, x plus 2, right? Is this the simplest form? A prime, just like you break down the numbers to prime. So this is a prime, so you just write x plus 2, right? A binomial. How about x minus 2? Is that a prime? Yes, you put a parenthesis around it, but they are different kind of things, so you write it separately. Then you line them up, right? So what's your LCD? You choose all the factors. So that will be your LCD. Just like 7 and 3 for the denominators, then 2 primes, right? If it's 1 7 and 1 third, and what's your LCD? 7 times 3, right? So it's like those. Number 3, you have 2 rational expressions. If we have to add or subtract them, we have to find the LCD first. So we figure out for the denominator in prime forms first. So this is what? Trinomial. How do we break down the trinomial to all the primes? DC method, right? But the leading coefficient is 1. We can just write it directly into it. So which two numbers will multiply together will be -6, added together is -1. That would be 3 and 2, and it's -3m plus 2, right? And for m squared plus 3m plus 2, trinomial leading coefficient is 1, so you have m and m, which two numbers multiply together is 2, added together is 3. So that will be 2 and 1, positive 2 and positive 1, right? But we need to line them up. So for each prime number, so for the group, so you need to write it this way. Instead of doing that, you write it here. M plus 2 lined up with m plus 2. M plus 1 would be there, right? So your LCD would be, choose all of them. That would be m minus 3, m plus 2, m plus 1, right? So that would be your LCD. Look at the next one. One is x minus 2, one is 2 minus x. They are very similar, but not quite, right? X minus 2, two terms, right? Binomial is a prime, right, in parentheses. How about 2 minus x? So you need to write it in what? Standard form first. So that will be -x plus 2, right? Then leading one is negative. Usually we take negative out. It will become what? Next, negative x minus 2, right? So if we line them up, it will look like this, right? Are they the same? Yes. One is positive, one is negative. If I have 5 and -5, so what's my LCD? We will just use 5. Usually we use positive number for the LCD. So we can just use LCD as what? X minus 2, right? You can use 2 minus x, but we always use what? Good looking one, right? Which is what? Standard form. So it's easier if you just use standard form, standard forms everywhere. So it's easier to compare, to check on them, right? That's it. Next step on your page 26 on the top. So if we have 1/2 plus 1/3, what do? We usually make 6, right? We find the denominators, LCD for the denominators first, right? Becomes 6. So you get LCD first, so you always what? Find the LCD first, right? Then second step, what would you do? You would change 1/2 and 1/3 to the same denominator, right? So you will convert each, right? Instead of rational numbers, we do what? Each rational expressions, right? To what? LCD form, right? That's what we are going to do. So how do we do that? You times 3, right? You do the bottom, you do the same thing on the top. Then you times 2, that would be 2, right? That's how we do. So first you find your LCD 6, then you convert each numbers fractions, rational numbers, or rational expressions to LCD form, right? We did. Then what do we do? After that, how do we find the answer? We will subtract the numerators, right? So we will subtract the numerators. And how about the denominator? Denominator will remain the same, right? So once you combine the numerators, then you will write it over the LCD, right? That's what we do. Then after that, what do we do? This one is okay, but sometimes we need to simplify, right? If possible. So what are we doing? We are going to subtract fractions with unlike denominators, different denominators. So we use LCD. That means for several fractions, we want to write the answer. It's just one fraction, okay? The simplest form. So you want to write your answer as simple as possible. That's what we are doing, right? Then let's look at the next one for the rational expressions. So, is this a rational expression? Right. And minus another rational expression, right? It's just two fractions. We have unlike denominators, so we need to find the LCD, which is 15, right? Then this one has to times 3, that would be 6x, right? Then this one, same, so we don't have to do anything for that. Then we already converted each rational expression to LCD form. Then we will combine the top minus, that would be 6x minus 6x is 0, right? Then you don't leave answer there. Why? Because that's not simplest way to show a number. 0 divided by 15 is what? 0. So you need to write the answer the simplest form. Got an idea? Right? Then for this one, what do you think? First, find the LCD. What's your LCD for 8a and 12a squared? 8 and 12, which is 24. If you do your trees, you find out. Right? Yes, 8 can go into 24, 12 can go into 24. How about a and a squared? Which one both can go into? You need to use the higher power one, right? So that would be a squared. So that's your LCD. Right? Then you have to figure out, okay, change both fractions to the same LCD form. From 8a to be 24a squared, you need to multiply a 3 and another extra a for that, right? Become a squared. Then you need to do the same thing on the top. That would be what? 21a, right? Then for the second expression, you need to multiply it by what? 2. Right? So we have same form now, same LCD form, right? Then combine the top. So that will be 21a plus 2, 24a squared, right? Then simplify if possible. Can we simplify more? Can you just cross out 2 and 24? We say, don't do that. Because 2 is what? Part of a group. You cannot cancel out part of a group with another group things. Remember that. And this is the prime. You don't need a parenthesis for the answer, but just for reminding you, you can do that. So you know you should stop right there. That would be the prime on the top, which is what? Binomial, right? Okay, so that's our example 2. Let's look at the example 3. 6x over x squared minus 4 minus 3x plus 2. Right? So you have 2 fractions. And we want to write what? As one fraction. So, to find the LCD first, you have to check on the denominators, right? So, can we break down this to the prime form? So, first, we write in prime forms, right? So, x squared minus 4. A squared minus b squared is what? Still remember your factoring? The difference of 2 squares, right? So that will be what? A plus b, a minus b, right? So that's x squared and 2 squares. So you have x squared, x plus 2, x minus 2, right? That's a 6x. Here is x plus 2 and 3. Then it's x plus 2, a prime? Yes. Put a parenthesis around it, right? So, then you will write in what? LCD form. So, what's your LCD for x plus 2, x minus 2, and x plus 2, right? So, your LCD will be what? You need both. So, that will be your LCD, x plus 2, x minus 2. You will write both the same LCD form, right? Then, this one is the same for the second rational expression. Oops, now this guy. This guy is extra. X minus 2 is extra, right? So, if this is extra, you need to multiply bottom and the same thing for the top. So this one is that, right? Then what do we have? Okay, then we'll combine the top because since we have same LCD, so we just combine them, right? 6x minus 3 times x minus 2, right? At this point in time, remember, don't cross out your x minus 2 because on the top, it's part of the whole group. Then, on the bottom, you have different primes. Okay, so don't cancel them. You need to what? Combine the like terms to simplify it on the top first. You distribute your -3 first. right? Okay, then what's on the top? 3x plus 6, x plus 2, x minus 2, right? Then you have to decide, are we done or not? You need to check. So you need to check if it's a prime or not. Is a prime on the top? Not quite, because you can take the 3 out, right? So it becomes 3 times x plus 2. On the bottom, it's the same. Now, can you cancel out your x plus 2? Yes, because as long as you have what? Something multiply something, right? As long as they are multiplication and factoring form, then for each factor, you can cancel out. So your final answer will be what? 3 divided by x plus 2, right? You just need to do a lot of practice so you don't make mistakes that much. Let's look at the next one. 3 over 5y plus 2 over what? Y plus 1. So what's your LCD? 5y and y plus 1. Y plus 1 is what? A prime binomial. Put the parentheses around it. Okay, so that's that. So what's your LCD? If you line them up, that would be 5y and the y plus 1 multiplying together. Is that right? So you should have 5y, y plus 1. You should have 5y, y plus 1, right? Then for this one, y plus 1 is extra. For this one, is 5y is extra, right? So this one extra, you need to multiply same thing on the top. This one, 5y is extra, you need to put the extra on the top as well, right? This one was 3, this one was 2. Right? Then we will combine the top, that's 10y, right? And over the what? The LCD. Do you cancel y plus 1 at this point of time? I keep repeating. Don't do that. Okay, this is all multiplying. This part you have adding, then it's now all multiplying. You cannot cancel part of it, okay, unless it's factoring form or multiplication. Then you need to combine the top. Simplify it, would be 3y plus 10y would be 13y plus what? 3. Right? This way. Do you cancel y and y there? We said what? Don't do that. This is a prime. Right? So that would be your answer. Right? Okay. Think about what we are doing. Right? What are we doing? Adding and subtracting rational expressions, the fractions. So make many fractions simpler with just one answer, with the answer just with what? One fraction. That's what we are doing, right? Then next one, number 5. For this situation, x minus 3, 3 minus x is very similar, right? Then we write it in standard form. That would be what? Negative x plus 3, right? So first, you write it in standard form, right? Then we say next one, we will write it in what? A prime form. Right? So you take a negative out. Oops. You need to do what? Change the sign inside, right? Then what do? You move the negative away from the denominator. Right? You move to outside, it becomes plus. Right? Does that look much better? Then you will just combine the top right over your LCD. Not too bad, right? So this one just one number plus some fractions. If we do 1 plus 5, 1/5, how do? You will put a 1 underneath, right? Then make the same denominator. Then you combine the numerators, right? Same thing for the rational expressions. So you put a 1 underneath, then between 1 and n plus 1, what do you think your LCD would be? That would be your n plus 1, right? Then that would be n plus 1, right? Like 5/5. So multiply the bottom, you multiply the top. Then what do? Combine the numerators, right? Do you cancel the m's here? Don't do that. Okay, so this is a prime binomial, this is a prime, a binomial. So that would be your answer, right? Let's look at the next one. 2x squared plus x and minus 2x over 6 plus 3. So first we check if they are in standard forms. Yes, they are. And next one, we will write them in what? Prime forms. So that will be 3 for this one. Binomial, are they in primes? Not really. So you do 2, oh, not 2, just x, right? Take x out, will be 2x plus 1. Am I right? Minus 2x, take a 3 out, will be 2x plus 1, right? Then, what do you think your L? That's prime forms in primes, right? Then you write in what? LCD form for next. X, 2x plus 1 the same. You have x extra, you have 3 extra. So you need both. 3x, 2x plus 1, right? You need a 3x, 2x plus 1. Then, for the first fraction, we have what? 3 is the extra one, so you need to do the same thing on the top. And for the second fraction, x is the extra one, you need to do extra, only numerator. right? So it was 3 here, it was 2x here, right? Then what's the next step? Combine the numerators. So that would be 9 minus what? 2x squared. Okay? You can just leave the answer as such because that's the final answer. Then you cannot break down anymore. That's prime. Then nothing to cancel. So that will be your answer. If you want to write it in standard form, you can write it this way as well, right? I think your computer will take both. As long as they are a simplest form, right? So, okay, for number 8, we have 2x over x squared plus 2x plus 1. A fraction add to another fraction. So first we check if it's a standard form, right? Yes. Okay. The next one, we'll have to write it in LCD. So we have to do the what? Prime forms first. So we will write it in primes, right? For trinomial, 2x, x squared, oops. So we will break down to the primes. So that would be x plus 1, x plus 1, right? Then plus x. X squared minus 1 is what? The difference of two squares. So that will be a squared minus b squared equals a plus b times a minus b. So it's x and 1. So plus and minus 1, right? Then next one, we are going to write in LCD form. So for LCD, for x plus 1 and x plus 1, right? For the first one, next one will be x plus 1 and x minus 1. So for the LCD, that would be what? Need one of those, another one, x plus 1 and x minus 1, right? So next, we write in the LCD form. So that would be what? The same LCD, right? So x plus 1, x plus 1, and x minus 1. For the first fraction, this is extra, right? So you multiply the top as well. Then for the second fraction, this is extra, so we do that. Then multiply back to the original. Then we will combine the top right over the LCD, right? So for this one will be what? 2x squared minus 2x. For this one will be what? Plus x squared plus x, right? Then we simplify the top. That would be 3x squared minus x, right? And over the LCD. Then we have to check if this is the simplest form, right? By doing what? To check it. So you will see the top is prime or not. It is not. So you factor it again. So to see if anything, you should cancel them out. So for this case, can we cancel out anything? Not really, right? So this would be the simplest form. So, or you can answer you can put answer that way because that's the simplest one. We cannot cancel anything anymore, right? So we did what? Add, subtract, multiply, and divide rational expressions, polynomials in fraction form. But we say for this class, we only learn one thing, which is solving quadratic equation. We find out why we are learning fractions, how we are going to do fraction things for the purpose of what? Solving quadratic equations. Okay? We will get there next time. So this will be our sections 8.3 and 8.4. We finished the page 26.